This chapter goes further in dealing with percents and proportions. For example, you can use a proportion or multiplication to find the percent of a number. Now we know that 25% is 0.25 of 84. Well, that's 0.25 times 84, which is going to be, 0.25 is 1 over 4, and we cancel it to give us 21. And what number is 15% of 300? Well, that's equal to 0.15 times 300. So you can cancel things out, and it'd be like 15 times 3, which is 45. So, let's find these numbers. Find 20% of 55. Well, that's equal to 0.20 times 55. It's 1/5 times 55. Well, okay, then it's going to be 11. So find 190% of 40. Well, 190% is 1.90 times 40. 1.9 times 40 is equal to 19 times 4. So that's 76. Now what is 12.5% of 70? Well, that's equal to 0.125 times 70. Or 1.25 times 7. Which gives us a 1.75 at the end. And then 1 times 7 gives us 7. So we get 8.75. Or we could go with, well, we know 1.25 is 1/8 of 10. When we got to 1.25 times 7, we could have gone 1.25 times 8 minus 1.25. In other words, 10 minus 1.25. Okay, 0.4% of 40. Well, that's equal to 0.004 times 40. So we move the decimal place by 1 and get rid of that. So, and then times 4, which leaves us with 0.16. So, what is 3% of $300? Well, that's equal to 0.03 times $300. By canceling, we can get easily down to 3 times 3, which is 9. And there are units here, so it's dollars. Depending on convention, you may be supposed to write the dollars in front, but whatever. What is 0.7% of 180? Well, that's 0.007 times 180. Everyone is perfectly welcome to do this stuff by mental math if they like, or by hand, but I'm gonna save myself a bit of time. 0.007 times 180, 1.26. Does this look reasonable? Well, let's see. We start off with 0.07 times 18, which is going to be a bit less than 0.07 times 20, which would have been 1.4. Specifically, it's going to be a tenth less than that. So 1.4 minus 0.14. Okay, 1.26. Wonderful. A percent proportion. This compares part of a quantity to a whole quantity for one ratio and lists the percent as a number over 100 for the other ratio. You can also say that this is equal to percent, well, percentage, depending on what your area calls it. And then this symbol, which is over 100, really. So what percent of 24 is 18? Well, 18 over 24 equals, well, okay, let this be x. Okay, so 18 over 24, the part over the whole, is equal to x over 100. All right, then we cross multiply, do we? Actually, we can do some canceling first. So 3 over 4 is equal to x over 100. 300 is equal to 4x. X is therefore equal to 75. 18 is 75% of 24. Okay, so what number is 60% of 150? This is x. Okay, so we stated that bit. What number is 60% of 150? So 60 over, oh, that's not a very nice 6. 60 over 100 is equal to part over whole. So x over 150. First you cross out that. Then, what else can you cross out? You can cross out that. So you end up with x is equal to 6 times 15, which is equal to 90. So our statement is 90 is 60% of 150. So yeah, usually for statements you restate the problem. But for some questions, sometimes it's a bit less awkward to reorder the problem and restate all the parts of it with the answer attached, of course. So exercises. Let's find each of these numbers and round to the nearest tenth if necessary. What percent of 50 is 20? 20 over 50 is equal to 0.4 equals 40%. We know that method. Okay, what else could we do? Oh, hey. So, percent is equal to, as a result, we can cancel these to get a 2 and a 1. Percent equals 40. Okay, then, how about we go unknowns are x for all problems below. Because writing let statements for all of them is kind of irritating. 33 is 75% of what number? 33 over x is equal to 75 over 100. But hey, you can cancel this to give us 3 over 4. So 3x is equal to 4 times 33. 132. X is equal to 44. You could also have gone and canceled this to be 11 and this to be 1 beforehand. So 40% of what number is 36? 40 over 100 is equal to 36 over x. And this cancels to 2 over 5. And you can cancel this again to a 1 and this to 18. So you end up with x equals 5 times 18. So x is equal to 90. 40% of 90 is 36. 12 is what percent of 30? 12 over 30 is equal to x over 100. So, cancel out a 10 from the denominator of each side. This cancels to a 4 and this to a 1. Therefore, x is equal to 4 times 10. Because you multiply the 10 over. And x is equal to 40. Estimations and percents. To estimate the percent of a number, you can use a fraction or round to the nearest multiple of 10% or 1%. So let's estimate 72% of 700. Okay, this is approximately 70% times 700. So that is equal to 0.7 times 700. Yeah, that's about 490. Actually, because we know we rounded down, if we were to give a rounding at the end as well, it would be approximately 500. It's actually 504, because 2% of 700 is also known as 2 times 7, which is 14. So, yeah. So this is reasonably close. 139% of 70, well, that's approximately 1.4 times 70, which is 7 times 14, or 7 times 7 times 2, so 49 times 2, which gives us 98. This is an approximation. It's reasonably close. It's 1% of 70, i.e. 0.7 off. Now let's estimate 0.9% of 214. Well, you're going to be dealing with approximately 1%, so 0.01 times 200. You rounded the other one as well. Here. Because this, proportionately, you're rounding by a lot. Like 0.9% to 1% is 1/9 the difference. That's a lot. Compared to, say, 72% down to 70%, that's 1/36 the difference. So, yeah. If you're going to round by a lot on one of the numbers, the other one, if you can round in the opposite direction, you will want to, for multiplication problems, for your estimate to be actually reasonable, i.e. not completely out to lunch. So 0.01, 1% of 200 is approximately, well, actually it is 2, but we kept the approximation symbols because this was approximated from what we began with. What is this actually, though? Oh, 214 times 0.009, 1.926. So we're pretty close. Okay, let's estimate these. 81% of 25. Well, that's going to be approximately 0.80, or 0.8 times 25, which is approximately 20. 150% of 159 is approximately 1.5 times 160, which is going to be 240. 0.4% of 200, well, there are times when even if you're told to estimate, you cannot. Like when it's one digit on each that actually contains information that's not just the position, no. You aren't going to be estimating with those. Like, there's no point. It serves no useful purpose. I mean, sure, you can go like, oh, this is about 0.5% times 200, which is 1, but why would you? What? I don't even what? No. Don't do estimations when it's clearly just not making the calculation actually easier. Okay, so what happens? Well, you cancel out these and you put your new decimal there, or you can draw an arrow. And then it's 2 times 0.4 equals 0.8. 39% of 62 is approximately 0.4 times 60, which is 4 times 6, 24. Okay, 23% of 37. You can approximate this with 25% of 36, or you can go for 20% of 40. 0.2 times 40, which would give you 8. Yeah, needless to say, a lot of teachers wouldn't actually be very impressed with a 25% of 36, just because you don't usually round 37 to 36. Like, you go either for the nearest 5, in which case it's 35, or the nearest 10, which is 40. I mean, it's obvious that if you're eyeballing the problem, you're going to go for a quarter of 36, but, well, that's like too much sense. North American math curriculum cannot take. Yeah, okay. 139% of 52, so 1.4 times 50. Yeah, of course this is going to be a bit off, as estimates tend to be. Like, this is quite appreciably off, really, but whatever. It's an estimate. As long as you can rationalize to your teacher like why you made these decisions when making your estimate, generally it's like, oh, okay, whatever. The percent equation. To solve any type of percent problem, you can use the percent equation, which is part equals percent times base, where the percent is written as a decimal. Why don't you just say fraction times base? Huh? Percents are fractions. But hey, North American math curriculum, you kind of need to be aware that this is just how they do it. Even if it's not particularly good for getting students to grasp why this is so, and it's more like just, you must remember this, but thou must. There's actually a trope called, but thou must. But, well, okay. 600 is what percent of 750? Let this be X. Okay, 600 is equal to... Look, I know the equation listed up there puts the x in front of the 750, so percent times base, but really nobody cares. So we're going with 750x. That's writing. No need for brackets. Wonderful. So x is equal to 600 over 750, and as we know, this has got to be 4 over 5 because they're multiples of 150, specifically 4 times 150 over 5 times 150. Okay, 45 is 90% of what number? Let this be x. Okay, so 45 is 90% of x. Therefore, 45 is equal to 0.90 x. X is equal to 45 divided by 0.9, also known as 50. Exercises. Write an equation for each problem, then solve. Round to the nearest tenth if necessary. That means tenth of a percent if it's what percent? What percent of 52 is 13? 13 equals 52x. Okay, let's put a let statement for all these problems. Unknown is x for all problems below. So, x is equal to 13 over 52, which is 1/4 or 0.25, but wait a second, it says what percent? Therefore, x is equal to 25%. 36 is what percent of 40? 36 is equal to 40x. X is equal to 36 over 40, which of course is 9 over 10, which is 0.9, and that's 90%. We state that this is x here. 88 is 40% of what number? 88 is equal to 0.40 x. X is equal to 88 over 0.40. And that's going to be 220, because 22 times 4 is 88. X is equal to 220. 65% of what number is 78? Well, what number times 65% equals 78? Yeah, but the formula we had up there was 0.65x. If you're doing this problem on your own without it being in a section that's immediately after a formula like that, obviously for this you would put 0.65 times x, or just 0.65x, equals 78, because that's the order it's written in. But, well, so x is equal to 78 divided by 0.65. If you're not comfortable, you can have 0.65 moved over, and then on the next step you can flip the thing. 78 divided by 0.65 is equal to 120. Okay, what percent of 2,000 is 16? 16 equals 2,000x. X is equal to 16 divided by 2,000, which is going to be 8 over 1,000. Yeah, 8 over 1,000 is, of course, 0.008. And that's 0.8%. Now, what is 122% of 80? Well, X is equal to 1.22 times 80. Okay, then. 1.22 times 80. Oh, it's 97.6. Oh, wonderful. No rounding was required. Hurrah. But, did we forget something? Oh, yes. We should restate on the last line what we're equaling, even if we had just stated it one line prior. It's just a convention. Okay, so when we're solving problems, yes, this is the obligatory problem-solving section that you find in North American math textbooks for each chapter. Okay, so if we're trying to figure out if some answer that we got looks reasonable or not, we got to use rounding and estimation to determine what we kind of expect our answer to be. Like if you're multiplying something around 0.1 by something around 1,000 and you don't end up with a number somewhere in the vicinity of 100, you probably did something very interesting somewhere and should redo the problem. Now, if you're using a calculator to check your answer, yes, it does determine if the answer you found is in fact reasonable, but it also just determines straight out if the answer you found is right. If you're looking for actually determining if it looks reasonable or not, you should probably rely on mental math. Yes, contrary to what North American textbooks would tell you. Yeah, if you're running it through a calculator, you might as well just run it straight through. North America. Well, it can't be helped. Anyway, let's do some examples. There is a 9.5% sales tax on all purchases, so approximately 10% tax. Okay. Suppose a game costs $8.99, so about $9 pre-tax cost. Harriet figures that if she has $10, she'll have enough to buy the game. After adding in sales tax, is $10 a reasonable amount? Okay, so together, that's going to be approximately 0.1 times $9, which is equal to $0.9 tax. Total cost is approximately $9 plus $0.9, which is approximately $9.9. Yeah, $10 is a reasonable amount to bring. $10 is adequate and reasonable, but adequate kind of encapsulates that, at least as far as I understand. Exercises. The total bill at a restaurant for a family of 5 is $77.98. They want to leave a 20% tip. They decide to leave $15. Is this estimate reasonable? Explain your reasoning. 20% of $75 is $15. So for $77.98, It seems reasonable. Because 77.98 is pretty close to 75. But if they wanted to leave a minimum of 20% tip, then no, you should have gone with $16, guys. Yeah. Actually, we should probably state as 77.98 is close to 75. Okay, let's say we have a survey that shows 87% of students spend 3 or more hours on a computer per night. Suppose there are 1,211 students in your school. What would be a reasonable estimate of the number of students in your school who spend 3 or more hours on a computer per night? And explain your reasoning. 87% is approximately. This is one of the symbols that you may see for approximations. The other one is this version. So either one of these is okay. Just saying. So it's approximately 87.5%, which is 7/8. So 1,211 students, rounding to the nearest multiple of 8 is okay. 1,211 is approximately equal to 1,208. Nearest multiple of 8. Specifically, this is 8 times 151. So, 7/8 students spend 3 or more hours on a computer per night. 7/8 times 1,208 is equal to 1,208 minus 151, which would leave us at 1,057 students. Of course, this very likely is a bit more precise of an estimate than you are expected to produce. I wouldn't be surprised if you were expected to either go with 90% times 1,200 or 7/8 times 1,200. Well, there's our estimates. Explain your reasoning. Look at the math. The equations explain the reasoning. Yeah. So our statement would be approximately 1,057 students spend 3 or more hours on a computer per night. Now, if we actually calculated this, 1,211 times 0.87, we'd get 1,053.57, which means that most likely the actual survey says 1,054, or it could be that they only surveyed 100 students, and 87 of them spent 3 or more hours on a computer per night, and they extrapolate this to the rest of the students in the school, assuming that their sample is representative. Percent of change. It's a ratio that compares the change in quantity to the original amount. Like, say, decreased by 5%. That means there's 5% less now than there used to be. The amount that changed is 5% of the original amount. If the original quantity is increased, it's a percent of increase. If the original quantity is decreased, then it's a percent of decrease. Last year, we had 2,906 people attending a conference. This year, attendance was 2,950. What was the percent of change in attendance to the nearest whole percent? Well, then you're looking at 2,950 minus 2,906. So the change divided by the original amount, which was 2,906, which is, it's 44 over 2,906 divided by 2,906. Well, you may want to put this step, but of course it's optional, in my opinion. And then you actually use your calculator and you go, this is approximately 0.015141. And that's approximately 1.5%. Oh, nearest whole percent, huh? Okay, then that's 2%. Approximately. Yeah, that's really approximate, guys. John's grade on the first math exam was 97. His grade on the second math exam was 89. What was the percent of change in John's grade to the nearest whole percent? Well, the change was 89 minus 97, so negative 8, over the original amount, which was 97. Negative 8 over 97, and calculators. Negative 8 divided by 97 is approximately negative 0.08247, something. Which is nearest whole percent is going to be minus 8%. Now, if his first math exam was, say, 92, then you'd see that the percent of change would be slightly less of a, hey, this is just a quantity, right? Is it a proportion? Depends on if your initial grade was out of 100, really. But we don't pay too much attention to that. Exercises. Find each percent of change. Round to the nearest whole percent if necessary. State whether the percent of change is an increase or decrease. Original, 4. New, 5. Well, the change over the original, is a plus 1, or 5 minus 4, over 4. So say 1/4, or 25%. Original 1.0, new 1.7. Well, that's 1.7 minus 1.0 over 1.0, which leaves us with 0.7, or 70%. Original 313, new 300. 300 minus 313 over 313. So the change divided by the original. The change is negative 13, and the original 313. So we use our calculators. 313. Round to the nearest whole percent if necessary. Well, that puts us pretty firmly at approximately negative 4%. And then if you have the new being 721, the original was 990. The difference is the new minus the old. And you divide by the original. So 721 minus 990, negative 269 over 990. Divided by 990. Oh, it's approximately Negative 0.271717. Oh, okay. Yeah, so it repeats. And you would then go, this is approximately, it says, to the nearest whole percent, so negative 27%. State whether the percent of change is an increase or decrease. We have positives and we have negatives. Negative percents of change are decreases, and positive percents of change are increases. This should be explicit enough of a statement for general purposes. Wait. What if you don't have percents of change that are negative in your question? Well, then you would have to say 70% increase, or plus 70%, plus 25%. The plus symbols are needed if you don't have any negative symbols to contrast with. All right, sales taxes and discounts. Sales taxes are percent of the purchase price, and they're paid in addition to the purchase price. So basically you multiply the price times 1 plus tax, with the tax being the decimal here. So, a discount is a proportion or amount by which the regular price is reduced and should be applied before sales tax if both are present. In other words, discount, like some multiple, D, times price times 1 plus sales tax. Like, you don't apply the discount to the base price after you stick the sales tax on additively. If you're doing the sales tax multiplicatively, though, well, your discount is also multiplied in, so it doesn't actually matter the order. Find the total price of a $19.75 soccer ball if the sales tax is 8%. Well, you're looking at 19.75 times 1.08 equals 19.75 times 1.08 equals $21.33. This is the total price of your soccer ball. 1.08 is because the original price, well, times 1, perfectly reasonable, plus 0.08 times this thing. Oh, hey, we just factor out the original price. So yeah, by paying 8% sales tax, you are paying 108% of the original price in total after tax. It's 100% of the price plus the 8% tax, in case it's not too clear for you guys. So, example 2, find the price of a $69.50 tennis racket that is on sale for 20% off. Then find the actual price paid after charging 6% sales tax. Well, $69.50 times 1 minus 0.20. By the way, when we use D up there, we meant like the discounted price ratio. Like a 20% off, that's 80% price. So if you're using discount as the proportion that's removed from the original price, then you gotta use the 1 minus that proportion. If you use sale at 50% price, or sale at 60% price, then it's just times 0.6. So you gotta make sure you look carefully to see if it says 60% price or 60% off, or however much price, however much off. There's a big difference, except when it's 50%, of course. So this 69.50 times 0.80. So 69.5 times 0.8. 55.60 dollars. Okay, actual price paid after charging 6% sales tax? Well, 55.60 times 1.06 for the 6% sales tax, 1 plus 0.06 is 6 is 58.936, which should be approximately $58.94. Yeah, the actual price paid after the 6% sales tax when the racket is 20% off is approximately $58.94. You could totally have multiplied these just in a row, as we will soon see. Find the total cost or sales price to the nearest cent. $23.95 shirt times 7% sales tax. Well, we're looking at 23.95 times 1.07, which is equal to 5 times 1.07, 25.6265, so approximately $25.63. $34 jeans at a 25% discount. Well, 25% discount means that the price is 25% lower. Which means you're looking at 34.00 times 1 minus 0.25, which is equal to 34 times 0.75 if your teacher's a stickler for steps. 0.75 times 34 is $25.50. Okay, what about a $35 belt with a 40% discount and 8% sales tax? That's a $35 times 1 minus 0.40, and then you multiply by 1 plus 0.08, or just 1.08. So 35 times 0.6 times 1.08, which is equal to 35 times 0.6 times 1.08, 22.68. And the units are dollars. Okay, let's say we have a $19.50 book, and we have a $2 discount from a coupon, and then we have a 6% sales tax. Hey, this sort of discount that's just an amount is different from this. It's different from a proportional discount. You just subtract directly. So 19.50 minus $2. And then you multiply by 1.06 for the 6% sales tax included. So you're looking at 17.5 times 1.06. 17.5 times 1.06. So that's 18.55. Make sure you understand the different forms of discounts and sales. If you get a proportional discount, you use 1 minus that proportion and you multiply that in. If you get a flat discount, like from a coupon, it's subtraction first from the original price, and then you multiply by all the other factors. If you get, say, sale at 40% price, then it's just going to be original price times 40%. Be very careful about the grammar. Simple interest. It's the amount of money that you earn for the use of money. The principal is the amount of money that's being deposited or invested, and the rate R is the annual interest rate written as a decimal. It's usually the annual interest rate. It could be monthly, or it could be every 2 months, or every 6 months, or every 3 months, or every 4 months. So these will vary somewhat, but you just pay attention to the units. It's usually the interest rate per year. We call this per annum. Per annum. Time T is the amount of time the money is invested in years. So let's do some examples. Find the simple interest earned in a savings account where $136 is deposited for 2 years if the interest rate is 7.5% per year. Well, the interest is equal to the principal times the interest rate times the time. Rate should be given as rate per period, and time should be given in number of periods. In this case, it's 7.5% per year. So, okay, time is in years. Wonderful. The units cancel out correctly. 136 times a rate of 0.075 times 2. So, simple interest is a flat rate, as in the interest is not added to the principal for the calculation for the next period. It's not like, oh, I have $100, 10% interest, oh, I now have $110. And then I get 10% on that, I now have $121. I get 10% on that, I have $133.1. That is compound interest and will be covered later. For now, we consider $100 to be the principal, and then we earn $10 interest. And then we earn $10 interest again, $10 interest again. And the interest is counted separately from the principal. That is simple interest. So this is 136 times 0.15. 136 times 0.15. So that's equal to 20.4. And this is, of course, in dollars. Example 2. Find the simple interest for $600 invested at 8.5% for 6 months. So, we're looking at interest is equal to principal times rate per time period times the number of time periods. So that's $600 times 0.085, and 6 months is half a year. If there's no units given on the interest rate, it is per annum. That is a convention. So per year. 6 months is half a year, so 0.5. Now, 600 times 0.085 times 0.5 is $25.5. Well, usually you state all the cents if you state how many tens of cents there are. So yeah, the simple interest earned here is again $25.5. Let's do some exercises. Find the interest earned to the nearest cent for each principal interest rate per annum, unless otherwise stated, and time. Well, interest rate is equal to principal times the rate per period and the number of periods. So that's going to be 300, and the rate is 5% or 0.05. And then there are 2 periods. Therefore, you're looking at 300 times 0.1, so $30 is the interest rate. $650 at 8% in 3 years. ERT, $650 times the rate, which is 0.08, times the number of time periods, 3 years. 650 times 0.24 is $156 of simple interest. Now let's say we have a rather bigger deposit and a slightly lower interest rate. Because 8% is like pretty high. PRT 1575 times 0.045 times 4 years. We're going to be looking at 0.045 times 4 is going to be 0.18. 0.18 times 1575. So $283.50. This is I. What about 7235 at 7% per year and 2.5 years? Well, it's the same thing. We just multiply the principal, the amount of money initially put in, because that's how simple interest works, times the rate of interest per year, times the number of years, or the rate of interest per period times the number of periods. So that's 7235. So the rate is 0.07, so 7% per annum per year, and we have 2.5 years, so 2.5, which gives us 2.5 times 0.07 times 7235. So $1266.125, and that's approximately, because we go to the nearest cent, the interest was $1266.13. Okay, now for $665, the principal, the amount we initially start with, at a rate of 6.8% per year for 3 years, that's 665 times 0.068 times 3 years. So 665 times 0.068 times 3, $135.66. That's the interest. Now, what if we deposited at 1% per month instead? Then we would have to convert this to months, the time. Otherwise, we end up with however many dollars times year per month, which means the units don't work out for what we want. That would be bad. So the interest is equal to the principal times the interest rate times the time. Principal is 2105. The interest rate is 1%, so 0.01. And then the time, because the rate is per month, the time must be converted to months. 1 3/4 times 12 months per year. 1 3/4 years times 12 months per year. Okay, the years cancel out, so we're left with months. Great. That means this bracket is reasonable. Because if you end up getting funny units, you probably did something very bad somewhere. So it's 21.05 times 1 3/4 times 12. That's 12 plus 9. 21. 21 times 21.05 is $442.05. Okay, what about $900 at 8.4% per year, because it said per year unless otherwise noted, and this is the convention for interest per year is standard. So we have 30 months though. Well then, we're going to have still PRT, principal rate time, but it's going to be 900 times 0.084 times the amount of time is 30 months divided by 12 months per year. So that leaves us with 5/2 or 2.5. 900 times 0.084 times 2.5. So $189. That's the interest. We don't need to put the .00 because it's a whole dollar amount. $4,275 at 2% per month and 3 months. 2% per month is actually really good. Like it's 25% flat interest per year. Whoa, that's a lot. 4275 times 0.02 times 3 months. Well, that's 4275 times 0.06, which gives us $256.50 for our simple interest. So that concludes this chapter on percents and some more proportions and, of course, simple interest. See you next chapter.